Okay. All right. Thank you very much for giving me the opportunity to present our work. It's a real honor to be here at SemDial 2020. So let's start now. My name is Jorge del Bosque Treviño. I am a PhD student at Queen Mary University of London, and I am part of the Cognitive Science Research Group and a member of the Computational Linguistics Lab and the Education Lab. I will present the work I did with my first advisor, Julian Huff, and Matt Purber, my second advisor, which I am super grateful to both of them. The title of her paper is Investigating the Semantic Wave in Tutorial Dialogues, an Annotation Scheme and Corpus Study on Analogy Components. Okay, so let's start with the motivation. When I started my PhD, I envisioned a conversational AI system that could be able to tailor explanations according to the person that was chatting with it. Whether the conversational partner was a cyclist, a chess player, someone from Austin, Texas, or Copenhagen, a lorry driver, a managing director, or a fan of Formula One or RuPaul Drag Queen's race, the system should be able to produce or elaborate utterances meaningful to each of those unique individuals. A system I entitled the Explanation Machine. I started my path, my path in my research, and I wrote a position paper about how an explanation machine could tailor explanations using short-term common ground, as in grounding communication in terms of Clark and Brennan, and long-term common ground, as in common knowledge, mutual belief, joint knowledge, in terms of, again, Herbert Clark and Stalnaker and Lewis, and how this could help build better conversational systems like the Google Assistant, Alexa, Cortana, Siri, and some other agents which today sometimes help people and sometimes just frustrate them. People yell at them because we know speech recognition is difficult and natural language understanding is also difficult, and also maybe because of the lack of their capacity to tailor or personalize their responses. After this paper, I did a short corpus study, which I haven't published. And what I did was to look into the British National Corpus, particularly in human-human tutorial dialogues. And I found that the main linguistic device that conversational partners utilize while explaining concepts in tutoring or in training sessions are idioms and analogies. And I decided to investigate deeper about how analogical components like the base and target, or source and target, are grounded in tutoring dialogues. Now, after this brief introduction, I will move on to the background of the presentation. Firstly, regarding explanations and analogy. People continuously search, create, and evaluate explanations, and our capacity to explain or explanatory capacity is similar to our ability to reason analogically. Analogy is a cognitive process which involves the use of a source domain and a target domain. For example, if I say writing a paper is like cooking a pizza, the source domain is Italian cuisine and the target domain is scientific writing. Or like in this example from the computer science tutorial dialogues, in which the tutor says, this one here in the middle, the tutor says, it says, the stack is a little like a Lego set, okay? In this case, the stack, which is a computer science data structure, is the target, and the Lego set is the base. So I wanted to show this example because the rest will make much more sense when we go forward in the presentation. Right, so analogies are used extensively in explanations in instructional texts, especially while introducing a topic. And also they are widely used in one-to-one tutoring sessions to explain concepts to students. Now, regarding tutorial dialogues, human one-to-one tutoring is a very effective form of instruction and one of the most effective methods of helping students to learn. The problem is that many variables affect learning gains. For example, the domain, the tutor features, the student characteristics, and the session structure. And finally, there are pedagogical strategies like positive feedback, negative feedback, direct declarative instruction, or direct procedural instructions, worked out examples and analogies which have been tested empirically for their efficacy. And finally, in terms of the background, from Legitimation Code Theory, or LCT, is a framework for an effective explanation in the classroom or lectures or teacher presentations or pedagogical monologues. According to the semantic waves, the complexity of meanings varies in terms of semantic density and semantic gravity. The one I want to bring the attention to in this slide is the semantic gravity, which in essence distinguishes between abstract concepts and concrete real-world examples. Let's see in this illustration on the right, in which the explained concept is algorithms, defined as precise sequence or steps, followed by they are like instructions or recipes. And finally, moving back to the abstract instance of the explanations. And again, here is an example of the corpus we are using for this investigation. So with this background in place, we then elaborate this research questions. Can we develop a robust annotation scheme for making utterances in tutorial dialogues as belonging to the base and target components of analogies? Do human tutors adhere to the semantic wave shape over time in their analogical explanations? And the last one, what kind of semantic wave shape do we see in tutorial dialogues? Let's move on to the annotation scheme development section of the presentation. We used the British National Corpus in its 1994 version. We used the BEEC, which is the British Electric and Electronic Corpus, and the Computer Science Tutorial Dialogues developed by Barbara Diogenio and her colleagues. What we see now in this examples we made available to the annotators as part of the annotation scheme. We see, for example, that the tutor says, okay, this one we already looked into it, but if we looked into the second one, the tutor says, oh, a binary search tree is, and then repairing, this is the child's notation, if you're familiar with it, or child's child's. So back, a binary search tree is one way of looking at it. It's like a family tree. So family tree is the base of the analogy, and binary search tree is the target of the analogy. And finally, regarding linked lists, the tutors, because there's a couple of tutors, they used this analogy of a movie line or queuing at the movie theater. Now, I'll show you the results of the 3 iterations of the annotation scheme. As you can see in the slide, in iteration one, we didn't achieve a proper inter-annotator agreement. We used to non-native English speakers, so we changed them. We changed that for the next iteration. So we only reached 0.544. So there's three annotators, annotator 1, annotator 2, and G is what we assume to be the gold standard or the ground truth, which is the first author's annotations. Right, so this was the result of the first iteration. Not only we changed to native speakers, but we also added rules that contemplated the use of anaphora. And as you can see, we got really good inter-annotator agreement regarding the base component of the analogy, but we got a really bad agreement in terms of the target. We persisted into a third iteration. We changed one annotator and added clearer explanations about what constituted the target component. And finally, we achieved a very good inter-annotator agreement with higher than 0.77, and we proceeded to annotate all the analogical episodes of the corpus, which contains around 2,500 utterances with analogies or within analogical episodes, and around 1,300 we added as context before and after each analogical episode. Specifically, 5 utterances before and 5 utterances after every analogical episode. We can see in the distribution graphic the number of utterances per analogical episode on the left. And on the right part of the screen, we can see a pie chart showing how frequent the analogical components are within the total amount of utterances we analyzed. Now, this graphic on the left is showing how around 9 or 7 analogical episodes does not contain any wave at all. We can all, this part, if you can see my mouse pointer. We can also see that the majority of the episodes have only 1 wave, but we can also see that some of them have 2, 3, or more waves. And we even have 1 episode with 16 waves, which is quite an outlier. And on the right part of the screen, we see a depiction of a point break wave. And we're taking from the surfing domain the name of the waves. That's also why I have this background for you not to forget about waves. And where this one in particular is a massive wave, like the one from the movie Point Break. Now let's see how this plays out in the dialogue. So in red, we have nouns or noun phrases which belong to the target domain, and in blue, the ones that belong to the base domain. So let's have a look to the dialogue. So this is just a tutor in this particular section. All right, stack is a very simple data structure. So we are in the target. This is a shorter and shorter stack of paper, and it has a top sheet. You can pick up the top sheet, or you can put another sheet on the top. So here is the base domain, and he keeps going on talking about operations, pop, stack, destructive functions, top elements, everything which is related to the target component. So this other graphic is also about point break waves. This is 2 other types of these waves. This is called the descending point break wave, in which we have the target descending to an utterance which has base and target, descending all the way down to an utterance with just a base, and going back again to the target, depicting an utterance which only has the target component. And in a similar way, the point break wave ascending, it has this type of movement, in which is immediately going from the target to the base and then progressively going back to the target. So these are the first three types of waves we characterize. And then we have, let's say, the medium-sized type of waves, which we call the reef break waves, again, from the surfing domain. And we can see this sequence in which we have target, base, and target, and then target. The second sequence, which starts in a base and target component, in a base and target, in an utterance containing base and target, and then going down and up. And this one, which is in essence a mirrored instance of the previous one. And finally, no, still not finally. This, well, finally, in terms of the categories of semantic waves, this is still reef break. Okay, yes, I'm taking the same one, the reef break wave, and I want to show you an example. This is interesting as well because we see an utterance which is mixing base and target. So the tutor says it's destructive. It takes, this means letter, the at L means the letter Q. So it's destructive. It takes the letter Q off and gives you the top element, what I call the letter N, and this means unintelligible. The insert is called a push, and this comes from the spring, popping this thing up, and the spring pushing down, and you push on the stack some value, letter N. So the spring is actually something he explains at the beginning of the dialogue. He talks about a spring and trays in a cafeteria and how a string is popping up things. So this is an example of an utterance that contains both the base and the target. And finally, he keeps going, just talking about functions, popped off, and evidently the target domain. Okay, just one last example. And this one, the tutor says, a binary tree is a kind of like mother and father and then the student, a family tree. And then the tutor says, no, that's not bad. That's bad. We don't know what's that. That's why there is, I mean, as far as our annotation scheme, this is not relevant. So we put an N that means neither of base or target. And then he continues and says, it's because families can have more than 2 kids, again, within the base. And he goes upwards to the base and target, finally closing by saying, so here what it means is that binary is that each node can have 2 trees, comma, 2 children. Right.
I want to remind our speaker we only have 5 minutes left.
Thank you. It's right. And finally, I want to show you a chart with the distribution of the semantic wave types. We can see in green hues or the upper part of the graphic how the 3 types of point break waves account for a bit more than the half of the a bit more for the half of the waves, and that the yellow or beach break waves are at the least prominent with only a little bit more than 10% of them. And then the other type of waves with less than 40%. And this is the final part of the second part. This is the ending of the second part of the presentation. And so I'm gonna move on to the final slide, which is our contributions. So the first one, we have shown that the semantic wave in explanations from legitimation code theory applies regularly in real tutorial dialogues empirically, suggesting it's an effective analogical explanation structure. The second contribution, to our knowledge, this is the first empirical validation of the concept from the legitimation code theory in tutorial dialogues. And this is motivated by building more effective tutorial dialogue systems, which consider the sequential unfolding of analogy structures in their decisions. And the final contribution, we present this toolkit that could be used for the design of pedagogical strategies in human tutorial dialogue and in intelligent tutoring systems. And that's the end of my presentation. Thank you very much.